Okay. Right. So I guess the thing really, Patrick, is for you to tell me where this flowchart is wrong.
Uh-huh. And oops, I will do it. Truth. Mm-hmm.
If you want me to scroll it, just say.
Mm-hmm. I'm just thinking. Mm-hmm. Oh, okay, this is nice. This I didn't consider before, because you have this uh, priority updating before we check the desired level. This is very good because in the old design, I guess there was the problem that if the goal did not make it to the desired level, uh, its priority was not updated.
Oh,
So
okay.
so this I think this design is better because if also also if it does not make it into it should adjust its score according to satisfaction. Its priority, I mean. Mm-hmm. This part looks right to me so far. I will check
Okay.
further.
Good. And just a comment, you mentioned the other day that you didn't think the logic for checking the truth table needed to be in here. I thought about that. And I think, in fact, it's actually simpler logic than what you must have at the moment, because currently, if the truth table exists, presumably you have to check to see whether it's empty or not before you try and get a value from it. Because it could be an empty truth table.
This is true. There's a NAR check. If the returned task is NAR, then just
Right.
red.
So this is, it's the same test, except this, if the truth table doesn't exist, it's empty basically. Because if it does exist, there must be something in it. So I guess it's the same check. It's just checking a slightly different point.
Mm-hmm.
Okay. So I scroll that up a bit so you see the bottom section.
Mm-hmm. At task to task link, then decide the mm-hmm. Decide the desired project to code. Mm-hmm. 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 One detail. If this one does not happen, sorry, if this one does happen and the task is added to the desired table, we should probably also do this step.
But there isn't anything in the desire table to do that with. That was, oh, what you mean to produce,
Red
why would you do that if it's an empty desire table?
because the desired table, although we can't guarantee it, it should should strive to have tasks of updated occurrence then. And although it would be too expensive to update all the desires in the table each step, we can at least do so at the.
Oh, I see. Okay, so this is when you're selecting for general inference, you mean?
No, when you put it into the desire table, so that the desire table entries are updated.
Okay, but I thought you re-ranked it based on every task that appears in the concept anyway.
I'm not sure what you mean.
Okay, but the first step is here where we rank the desire table.
Right, the current moment.
Right, so everything in the desire table will be ranked anyway.
This is true. This is true. So,
So I do have a question here, which is about this revisable aspect. Does it only check the highest ranked desire value for revisability, or does it check the whole table till it finds one it can revise against, or get to the end and fail to revise?
this one, there's a bit of a story behind it. I can, but at first I want this one to be resolved, if it's no problem.
Okay, well, yeah, you're right. Let's close this one down first then. So I'm not sure what value you get at this point. I'm probably missing some subtlety here, but why projecting the task before you add it to the table makes any difference when the table is empty. So if it's the only thing that's in the table.
I agree. I agree that it does.
Okay.
From this perspective, it doesn't make a difference because if we evaluate the desires, we project them to the current moment anyway.
Yeah, it was something you said that made me think I've got something slightly wrong here, though, because it is an expensive process to rank this every step. Have you found a way of avoiding having to do that for every desire value?
This thing to rank. Oh no.
Oh, okay, right.
But it's not that expensive because we only need to do the projection and data analyzation, and we don't need to create a new task. We just need to do the new group. We calculate the group values of this.
Okay, no, that's fine. I just want to make sure I hadn't missed something there. Okay. Well, you're right. It's not hugely expensive. It's just an iteration through the table, but the table's not that big, so it's not a big issue.
And this thing, now I see what you meant with general inference. This is the thing which makes the difference. When the desire is added and we project it, it will mean that the task, which will, as you said, be used in general inference, will then be the projected one to the current moment, and I think this is better.
Yeah, you're right. As you say, for general inference, it makes sense for it to have been done. Okay. All right.
So we will put this one whenever we add it. Okay, then we are ready for the next point.
Okay, you're happy with that then?
I'm happy with this.
So the next question then was, when you're doing revising, do you only revise the highest ranked item with the task, or do you try and revise it with every element in the table?
In 170, it was that we just tried to revise with the best ranked entry in respect to the task.
Right.
But I'm not convinced anymore that it is the best strategy. I think, hmm,
Yeah, I mean,
um,
I agree, because I think the second entry in the table might be revisable, whereas the first one isn't.
mhm,
And I
because
think, and that's actually quite an important piece of information to be able to use.
mhm, and that's because for Jared, it is because the first task could have a base overlap,
Yeah,
evidential base overlap, and
yeah,
then in 170 the revision would just have failed, so there would no revision happen. But probably, uh, hmm, there are multiple possible strategies. I will I will at first show the extremes. In 170, it was the extreme that we use the best ranked, and if we have overlap, then we have bad luck. The other extreme would be iterating through all the desires and creating revision tasks whenever for all the entries where revision is possible.
oh,
This
for
would
all of
be
them. Okay.
this would be the second extreme. I mean,
Yeah,
I just present two extreme
but
strategies.
you're not going to ever use all of those, are you? You're only ever going to use one of them.
No, no, I'm just telling two two extreme
Oh, I see.
strategies.
Oh, okay. Right. Yeah, yeah, yeah. Okay, I understand.
So in 170, we took the extreme that we only use the best ranked, and if
Yeah,
this one has a overlap, bad luck,
yeah,
and the other extreme would be revising, trying to revise before of them, which can lead to multiple revised
yeah.
tasks.
Understand.
And then there are some intermediate strategies. The first one would be to only the first one, which I really like, is to only how should I say? Whenever we do ranking, we rank the entries according to a specific task. And probably the best thing would be that tasks which have an overlap with the task are not part of the ranking at all. The problem here would be that the evidential base overlap check is relatively expensive.
Yeah,
Um, um,
I think it's actually cheaper to do what I said here, is to rank it, and then search through the table till you find one that's revisable. It may be, I guess the worst case is average table length, um,
mhm,
which is
I
which is
agree.
which is better than having to do it for all of them. Yeah.
Mhm. I think this is one of the two best strategies. The second,
Okay.
the second strategy would be to have a to have a hmm, how should I say a index index counter relative to the task, and this index counter does the following thing when it, when it tries to revise with a entry and fails to the overlap, then it will increment, leading to the thing that next time uh, it won't, or maybe it's a big
Oh, okay. Yeah, you're
dictionary,
right. Because
it won't choose
yeah,
the same.
because every time, yeah, that makes sense. Because we're ranking this table every task, but only one of them or one or two of them is going to change. So we've already done all of that work previously. Oh, okay. And we could find a way of maintaining that state so we don't have to keep doing it every step. Yeah,
Mhm.
okay, that makes sense. Yeah, okay.
And it would be the other, how should I say, it would not have the bad property that if a overlap would happen with all the entries in the previous strategy, we would have to iterate, or while with this strategy, it would, for example, select the first entry and fail increment. Next time, if it happens, it will see, this one I had already, I will try this one, fails
Yeah.
increment again. Next time, it will know this one I had already, this one I had, sorry, the counter is already here, so it knows it has to take the next one. So this would be a possibility, but I think that for now we can use the simpler strategy to just use the, how should I say, to generally in ranking only allow these entries which have no overlap with the task.
Okay, we can do that, can't we? It's slightly more expensive, but we can optimize that later. Okay, yeah, that you're right. So, and then we only pick the highest ranked one, right?
Right. This would already be a better strategy than in 1.7.0, I think.
Yeah, it stood out as an issue for me that there'd be a lot of potentially useful desires that we weren't using because the first one had overlap. Yeah. All right. The other thing in here that's different is, we touched on it previously, but it's about the fact that we use the revised task to pass into the operation and threshold check. Excuse me. It doesn't go through the derived task cycle. It's processed immediately.
This is good.
Yeah,
this
you're
good.
okay with that? Okay.
I think it's better to have local inference in its own cycle, because this was also one of the issues in 1.7.0, that also derived tasks competed in the buffer.
Oh, in your buffer, yeah,
sometimes,
your buffer bag. Yes, of course.
and
Yeah.
sometimes this led to the fact that although the system revised something, it was busy with other things, and so did not let the revision happen.
Okay, now that makes sense.
And although most often it was not a big issue, but sometimes it was. Yes, I think local inference should really be inside the concept and not go through the cycle.
Good.
Not,
It's kind of a principle I've been trying to maintain in the system, that local inference doesn't generate any derived tasks.
This is a good thing.
Okay. And then the last point on this chart is question about ranking and deletion. I'm not convinced that removing the lowest ranked item is the right solution to make space in a table. I think they should be removed based on priority. And the reason I say that is, if we're continuously deleting the low confidence items, although given that they're projected low confidence items, we're potentially making it much harder for the system to do inductive abductive learning, because all the low confidence items are the first ones to go.
You don't agree. You know, or the entries in the data, they will have the same content.
Yeah, I understand they have the same content, but they have different truth occurrence times and different priority. So the thing is that they're projected inside the tables, so that their confidence is only relevant to the current task time. The next task, for example, if you have a task that happens to be quite a long way in the future and you project everything to a point far in the future, it may be that a current task ends up as being the one with the lowest confidence because it's not related to the one that's far in the future. So you end up deleting one that's current because it's the lowest confidence after it's projected, even though it's got a really high priority. And then the very next cycle, the system actually wants to use that one that's got it's got a high confidence in the current time moment, just not for the far in the future.
Yes,
So
I'm more happy with yours as the one. But I see the issue. The, uh, the thing is, if there would be no occurrence then it's obvious that it should delete the one with the lowest one because it should always use the statement where most evidence was collected. But when we add occurrence then to this thing, then it becomes a bit more tricky, and I see the issue. The, hmm, the thing is, because different occurrence then can mean something different, and this is the thing which I don't like in our strategy. Can you score up a bit?
yeah. Oh well, that's the bottom. Oh, sorry. You want to see up here, right?
Right.
Yeah.
Oh, yeah, this
I
was.
can make it. Let's fit it. Let's fit it on.
This is the. Oops.
I don't know if you can see. Yeah, it's too
This
small.
is the. This
Yeah.
is the compromise.
Yeah. This box here. Sorry, I'll stop scrolling now. There we go. Right.
This is the compromise. That we project them to the current moment.
Oh, it's the current. Sorry, you're right. It's the current moment. Yes, it's not the task moment. It's the current moment. Yeah, ignore me. I don't know why I said that. It's because this one is projected to the task time, but the ranking is done to the current moment. Yes, of course it is. That's because whatever you execute is going to be executed in the current moment. Yes. Okay. Ignore that. Right. You're right. I agree with that. Yeah. Sorry. I even made a note about that as well. So I wouldn't make that mistake again, and then I just did it again. Okay. No, that makes sense.
Right, because we evaluate according to current moment, I think it's still the best to kick those out which have lowest confidence. But
Yes.
it's still a bit of a compromise.
Yeah.
I mean, if there wouldn't be occurrence, then I would be 100% sure that the strategy is right. But with occurrence, then I know it's a strategy which works, but I'm not sure if there is not a better solution.
Okay. No, that makes sense. I think I wrote this comment before I'd made the connection between everything happens in the current moment. Yeah, in fact, I'd even made a comment up here after I realised it needs to project the current moment because it will execute in the current moment if the decision threshold is exceeded. Yes. Okay. No, I'm cool with that. That was my last question. Let me just check my notes, make sure I'm not missing anything. Yeah, we're okay with that. That's fine. Yep. No, that was good. I'm good on that.
I'm just wondering, because to some extent occurrence time is part of the semantics of a statement. From another viewpoint, one can see it as a property of the truth value, that the truth value is about certain times, so the time is part of truth. But to some extent, it's also part of the semantics, and this gives me the question on whether our memory structure is ideal when we consider them. But
yeah, I think.
But I don't have something better, so.
Yeah, no, I agree. The whole issue of time, for me, it always should have been involved from the very beginning, even as part of truth. I think time should have been, but I think we've gone too far down the road of it not being part of truth now to try and change that, because all of the logic rules are based on the fact that it's not part of truth. Ideally it would have been, but it's not, so we're not going to fix that now. Okay, can I bring up another flowchart? We've got these should be relatively straightforward in comparison. So this is for just local inference on belief, pretty much the same set of principles, but a simpler approach because there's no goal handling. I don't think there's anything complicated in here. If there's any issues with that, just let me know. Otherwise, I'll assume it's okay. And we could apply the same strategy to revision in here as we would in the goal handling, presumably.
It's totally right, but there's one question which strangely never came into my head before. Because for the desire values, because we are interested in whether we should execute, there we project to the current moment, but
yeah.
And I wonder what this would mean for beliefs. Imagine all the belief tasks would always be projected to current time.
Let me just go back, because it's kind of easier to think about it if it's attached to a goal.
I think for how should I say?
I know, because I think it's, well, okay, so you're right. I see what you mean. So there's two ways of thinking about this, really. The reason we're projecting to task time is so that we can calculate satisfaction. If we did it, but then that level of satisfaction is going to be used immediately in the next step, where we actually determine whether or not we execute this. Yeah.
This I fully agree. But there's one other aspect of it, namely to try to keep desires which are relevant in current moment. And I wonder if this property does not also apply to beliefs. Shouldn't be the current moment a stress for beliefs to stay in the task table, in the belief table?
Okay, so.
Do you see what I mean?
Well, yeah. No, I agree. In that particular case, then my question about whether or not it should be priority kind of comes back again, because it's not the current moment anymore; it's the task time. But then whether it should be current moment.
But what I mean, the belief table. It's totally fine to have beliefs of different occurrence time, but what I wonder is if we shouldn't try to keep these beliefs which are how should I say? those beliefs which are strong in respect to the current moment and kick the other out. I
Yeah.
mean, I mean, to some extent, this was already the case by having the task priority and the task budget, because in 170 it was always when a belief task came in, it became to its priority got decreased whenever it was selected. So it was always almost times the case that due to the task forgetting that currently incoming tasks were usually the ones which were considered more by the system.
Yeah, and there's another issue here as well, in fact, that the value we're calculating the satisfaction for may not be the same one we actually end up executing anyway. Because they're ranked differently.
This is fine, I think, because I think it's really sufficient to only update the priority, because if the priority of such desire course get low, it means the system won't consider them and execute the relevant parts. So I don't think that we need to hamper execution just because the incoming task itself is already relatively satisfied.
Oh, okay.
I don't think this is necessary. But to the belief tables, I'm a bit wondering whether this temporal aspect of referring tasks which are relevant in current moment should also be something which should be in the belief table, or if it's sufficient to have task forgetting. But I think task forgetting is sufficient. But it's still something I did not really think a lot about so far.
Yeah, I hadn't thought about it either. It's an interesting point. Okay, well, it's an easy one to try. It's easy enough to change the projection type, so we can try both and see what gives us better results.
Yes. Do you also have a flowchart for questions?
Yes, I do. Let's have a look. There we go. I've only done the section in local inference. I haven't done the general inference part yet.
This is fine. Let's check this one.
You see, this is an interesting point where we have to project a task time because we want the answer for the task that we're asking about. So we do need to project a task time here, which probably means we do need to do it in the other one as well.
In general inference, yes. In general inference, the belief also needs to be projected to the task time.
Yeah.
But
no, sorry, I was thinking about the discussion we just had about whether we should project truth tables to current time at the current moment as well. But here's an example where we shouldn't do that. And I'm just wondering if that's the same argument.
No, this is really a different case because in question answering and in general inference, we want to select a belief in respect to the task. Well, in revision, we just and in revision also. What I mean is, while in execution, we want to see if the desire value, how big it is in respect to now, because we want to see
execute it now. Yeah, that's true.
Right.
Yeah.
So it's a different case. So
Yeah.
so in revision, in general inference, and in question answering, we always want this one.
Yeah.
While in execution, we want to project the current moment.
Yeah, you're right. I think that makes sense. Okay, well, we can think about it some more, but I think it does make sense. Okay.
Mm-hmm. The confidence.
Oh, up there. Don't know. Let me put that back. I'm not sure that's going into the right place at the moment. It's moved for some reason. Where is the end of that? Oh, I see. This that should be down there. I don't know how that ended up moving, but it did. Right, that makes more sense now. Right.
If it's a better solution, update the best solution, update the budget. Can you scroll down? Thank you. This thing is right, but there is one thing which we should consider in local inference for belief. Can you go back to the belief chart? Namely, when the task enters the truth table, probably it's good to iterate the questions and see if the added
Oh, okay. Yeah, I understand. I didn't know whether you did that or not. All right. Okay,
if it
so
provides a better solution to the task.
yeah,
To the question, sorry.
yeah, I understand.
The same with desires for quests.
Okay, so that means maintaining a table of questions.
Right.
Okay.
But this is everything then. The question chart itself is right, I think, because when the question is processed, it should also do an initial search for best solution by going through the table, and the best solution is updated by this thing when we add to the belief table.
Okay.
So there's a difference between having between setting the initial solution and keeping the solution updated. We keep it updated when we add new beliefs. This is where we keep the questions updated and the solutions to the questions updated, while the initial solution is obtained like you showed in this chart.
Oh, on this one.
Right.
Okay. So this bit here, you don't carry the answer around in the task. You carry the answer in a question answer table inside the concept. Is that right?
Right.
Oh, okay.
So the best thing, and so we also did it, was just to keep a question table and with a fixed size
Yeah.
Right. This is it.
I'm just wondering whether or not that's necessary. Where are we? Let me go back to this one. I originally used to do it this way as well in Alan and under other versions. Eventually, I found I didn't need that to maintain this list. I mean, we can do it that way because it's not a huge issue. But I found that just maintaining the answer inside the task itself, if it's a question task, and updating the task directly with the next best answer worked. But as you say, I'll go on.
Yes, but this diagram only happens once when the question task is processed, right? So when in between a new answer arrives, we need this thing to update.
Oh, that's true. Okay, yeah, you're right. Okay, that is different in this case. All right, yeah. All right, so well, I'll put that in. It's certainly not a problem. It just means adding something to the concept structure. That's straightforward. Okay, so that's a good point.
And
then sorry, I was going to say that, but this is the same for Quest, by the way, isn't it? Except the difference is that you're using a desire table instead of a truth table. Otherwise, it's exactly the same, presumably.
I agree.
Okay.
And the thing, so this check should probably card. No.
It's the other half of this, isn't it? For the selective questions, that is slightly more complex, where it has to check complexity statements and things.
I think this check is not needed because when we derive a new question task, it doesn't have a solution yet, and we select the highest projected, so it just goes.
Yeah, you're right. You're right. It's my assumption that the task carried the answer in here. So if you get a derived task came in, it would have a solution attached to it that it would check. But in this case,
it will have a solution attached, but not after derivation already. But after this happens, after this happens, sorry, then the task will have a solution set for the first time, and it will be updated whenever a new belief task comes into this diagram. Do you see what I mean? That when the derived question task or the input question task has no solution at first. We need to find the solution.
No, I agree. So if it doesn't have a solution, then it just says no and carries on.
But this cannot happen if there is an entry in the belief table. No, this cannot happen.
Okay, let me think about this.
What I mean is, if there is an entry in the truth table, then there is a solution.
Yeah, I agree. The assumption here is that it's always better than the one that's already been assigned to the task.
This is right, but what I mean, there won't be any solution already assigned because we just directed. This flowchart is happening when we process the direct or input task for the first time.
But it could be a derived task.
Same for direct task. But the direct task needs to.
Oh no, you're right. It still won't have an answer. Yeah, you're right. Okay, you're right. Yes.
Because
fair enough.
It just got created, so
in fact, that's not required because it's always going to have the best solution. Right.
Right. It will have beginning with here. It will have a solution.
Yeah.
Except there is no entry in the truth table.
No, but then they won't have an answer. So. Oh well, there might be an answer in the truth table. We don't know that yet, but
Should we also capture the case where the truth table is empty in this diagram?
That's here. That's here.
Ah,
So if it's empty, then the task just gets passed through. Yeah.
Right. Okay. Then.
Okay. All right. So I need to modify the concept design to incorporate the questions, question tasks. Does that holds all types of question tasks, presumably, not just yes, no types?
No, this thing which is here only happens for yes, no, that.
Yeah, this bit does, but in the concept where we have a question table, which we haven't got yet. So if we create this list of questions that we have to check against, does it also check for selective questions as well?
No, the local inference based answer search is only for yes no questions.
Okay.
While questions with the mechanism for question variables we did not discuss yet. This one is done in general inference. So
okay.
So probably what we what should I say? Here if we go back to this one. So because it's if it's a question with a question variable, it will always have an empty truth table. So it will always go down this way.
Oh, okay.
And the other thing, since a concept with a question variable does not have a belief, this diagram won't be used in such a concept anyway. So we don't need an additional check for question variables. This is what
right.
My point is.
Okay. All right. Well, that wasn't too bad actually. In that case, it was pretty much mostly right. If you've got a little bit of time, it would be helpful if you could explain to me how the selective questions get answered in general inference. I came up with several ways of doing it, but I didn't know what the best one was. So if I transfer control to you, you might want to draw some pictures because I know you just love drawing pictures. Let me see if I can remember how to do this. Allow control.
There's a white spot. I think I can draw. Do you see it?
Okay.
Yep.
Do you want me to make? I can just give you a white screen.
Yes.
Or black screen even. Can you draw on there? Okay. There you go. Great.
That is great.
You know, there's a text tool you can use.
Oh.
If you look near the bottom under whiteboard, there's a text tool. And a rubber and boxes. And
no, please continue.
Yeah, we should have let you struggle on for a while first.
No. Nearly. So we come to the question answering for what questions, and as we see, this concept has one question task.
And that presumably is the cat concept, yeah?
Oh no, it's the what cat concept.
Oh, so you actually, okay, you name it with the variable name as well, okay.
Right. And this concept will never have a belief.
Yeah.
This concept will never have a desire.
It's atomic.
This is where the diagrams will solve. The diagram with the belief update won't interfere with what questions anyway, because there are no beliefs.
Right.
So the thing which needs to happen, as we see this concept, in order to answer this question in this concept, it needs to work together with two other concepts in this case. Sorry, this one I did not intend.
There'll be a cat concept in there, presumably somewhere.
I agree.
Okay.
This I wanted to drop. So there's a cat concept, and this cat concept is linked to this. And it's linked to this and linked to this. And we have this question task. And I will write this question task extra here again to show that this question task is not only linked from this concept, but also linked from this concept. I will probably delete this. So this question task we have here is a variable from the concept cat, because it got propagated. When this question entered, it propagated it to the sub concept. And so we have in this concept cat the what cat task. And what can happen now, general inference. Select task from concept cat not cat. Select general link.
Yeah.
So far we are. And now first work of that belief
okay. That's the bit I was missing. A choice rule for a task belief pair, where the task can be a question.
Right.
Oh, okay.
So this is everything.
Okay. So the task does have a solution attached to it as well as there being a set of questions and best answers inside the concept.
The best answer should be directly attached to the task. The
Okay.
concept itself has a fixed says question list array,
Yeah. Yeah.
and but the solution is directly stored in the question task. This is the best handling.
Okay. So just to make sure I understand all of this, then the choice rule itself is a specific general inference rule that says take a question and a belief, and then check that it answers the question. And if it does, yeah, okay, got it, right.
Right, and then just as task according to the solution. Okay, well, it is probably a wrong word here, but to this is the last thing, because we also have this in the locker, in the yes no question case, that if we have a good answer, then we can lower the priority. And the
Yeah.
same thing is here. We should use the same idea here.
Okay, so is there a choice rule in the DSL?
What?
Is there a choice rule in the meta rule DSL?
Oh no, because the choice rule is not generating any new conclusion. It's just assigning a solution to a
No,
question.
that's fine. I just wanted to check I hadn't missed something. So it's really it's an extension to general inference as opposed to part of general inference. So this is kind of a bolt on to allow questions to get answered as part of the general inference process.
Mm-hmm.
Okay, no, that makes sense. Okay, right.
All right. And this is everything.
Yeah, no, that's good. I had far more complicated versions than that, but I guess that makes it simpler, just using the choice rule as such. I was trying to work with what I had without adding something, and I was finding it a challenge. But just adding another rule in makes it straightforward. So yeah, okay.
Oh yes. Are there any further topics you want to discuss?
I'm good. I don't know about any of the other guys. If you want any further explanations now, I'm happy to go through stuff in more detail if you want.
Mm-hmm.
Sure.
Right. Let me see if I can get my screen back.
Are we recording this?
Yes.
Yeah.
Okay.
So do you want me to go through the local inference for goals?
You just a quick rundown, I guess. Like now that that's all sorted, I don't know what if Roman has any specific questions. I don't. But yeah, it'd be appreciated.
In fact, actually, it probably makes more sense to start with beliefs and then move on to goals.
Okay.
We won't make any of the changes we discussed. We'll just stick to what's here, and if any of the details around the changes come up, we can look at those at a later point.
Yeah, that's fine.
So beliefs, essentially, a belief task comes in here. If you remember and just to be clear on here, truth and desire, which I flip-flop backwards and forwards between the name of these, truth and desire tables are synonymous with belief and goal tables. They are the same things. I decided, in fact, that truth and goal. Sorry, I confused myself now. Truth and desire was actually more descriptive of what was going on there. So a truth table is really about truths and how those truths are projected, and the same for desire and how desires are projected.
Could you
So I
just
stuck
write
with
down,
that.
just to be clear, like, can you write down the synonyms just next to it
Yeah.
or something?
I will. So truth table equals belief table, and desire table equals goal table.
Beautiful.
And those names are all interchangeable. So I'll try and correct it where I've not been consistent, but they are equivalent. So if you see one or the other, it means the same thing. And then the idea,
just in terms of like reasoning about this and in future, should we stick to one pairing?
Well, yeah, that's what I'm saying. I personally think truth table, desire table makes the most sense. But because people have been using it differently for several years, like Patrick, for example, I don't mind if people refer to them as beliefs or goals tables either, but they mean the same thing. So long as we're clear that if you say truth table or belief table, it's the same thing, I don't think there's a problem.
I just noticed that I always use this combination.
Yeah, I know. That's what I was saying the other day. Yeah. So
clear as mud.
And the reason I mention those now is just so that we're clear on what we mean by them, but also the fact that they're created dynamically. So if you remember back, in fact, we jump back to concept as part of the bigger picture, put it in context. Come on. So in here, the data structures in here, which this is the bit we're talking about, the concept data structure, where we have this idea of atomic and non-atomic. So if it's an atomic concept, it just has task links and term links. If it's non-atomic, it has task links, term links, and beliefs and goals, or desires and truth. Okay, so that's why I'm mentioning that. And the idea is that truth and desire tables are created dynamically on demand. So they don't exist unless you need them. So when you create a concept, when you create a concept, you only create it as an atomic concept. And then if these elements are required, and it may be that you don't need them both at the same time. It may be that, well, at one point you only need a goal or a belief table. So you'd only create what you need. You don't ever create them both unless you actually need them both. So back to the belief. First time through, there won't be any truth table. So it doesn't exist. So we create the truth table. We add the task to the truth table. There's nothing else to do because it's the only one in there at this moment in time. So we now got a truth table of one item. We add the task to the task links, and we're done. Assuming further tasks arrive, further beliefs arrive, truth table exists. If it exists, we know there's at least one entry in there, so we're always going to do this. So we rank the table by projected confidence of the task time. So essentially, we're going to convert the confidence values of all the beliefs in the truth table based on their relevance to the task time. We then go to checking whether or not the task is revisable with elements in the truth table. And what we've decided here was that we would, when we build this table, we'll only include those elements that are revisable. So essentially, we check overlap, i.e. evidential overlap between the task and the entry we're ranking. And if there is no overlap, we project it and add it to the table. So in fact, this check may not actually be required anymore. It may
You mean
be.
add it to the results, right? To the ranking results?
Yeah.
Right.
Yeah, because what you said, you thought the best solution was to only include those ranked elements that were
Which have no
revisable.
overlap.
Yeah.
Right.
So in fact, I mean, really, all we actually need to do here is find the highest ranked revisable belief. We don't need to do anything with the rest. So if we find one, actually, we still have to do all of them because the last one might be the highest one. Yeah, we still have to do all of them, but we only need to store the highest ranked one for this particular operation. We need to maintain a list of them somewhere. But yeah, okay. Sorry guys, that was slight aside. Are you guys following that? Okay.
Yeah, it's essentially you want to filter the truth table to things that are revisable and only keep the top one.
Right.
Yeah, that's all we need at the end of the day because that's the one we're going to use. Yeah. I guess there's still a question mark here because it's possible that there are no revisable beliefs in the table, which means that this step can't happen.
It'll just
so
be
we
empty,
still need
right?
to do. I guess it would be empty. Yeah. So there were no revisable ones, therefore the table would be empty. So therefore we can't do the revised bit.
Yeah, that's fine.
Yeah.
This is fine, but can you switch shortly to this diagram? I just want to know if I missed a little thing which might be of relevance.
Sorry. Well, you want to go to the goal? Yeah.
Right. Only for shortly. Sorry. Can you scroll down? Thank you. Okay. No, it's fine.
Okay.
We already said that the revised one won't go through the inference process. So
Yeah.
in this case, we evaluate according to the revised task already. If this one is a yes, and if no, we use the not revised one.
Yeah.
Right.
Sorry.
Yeah. So as it says here, you use the revised goal if it exists, but if it doesn't exist, you have to use the task.
Okay.
Right.
Yeah.
At that revisable question mark there, is that can we just like map and filter the desire table at this point after to project it, and then do we reduce it down to only the revisable ones and choose only the top?
So let me go back to the shorter version. I mean, my original how it's designing 170 is that it basically does a check against the evidence trails at this point to see if it's revisable. But what we're saying is we're going to modify that slightly. So this test here it's an empty table test or not, as you said earlier. So
empty result test. Right.
Yeah, empty result list. Sorry, empty results. Yeah. So if this is an empty result list, then we can't revise. But if it's not, then there's basically the result is what we're going to revise with because the highest entry is the one we're going to keep.
Yep, that's fine. And that's more or less the same with local inference for goal at the same point.
Yeah. At that point, it's the same process. Yeah, it's the same process. So we revise with the highest ranked belief. That becomes the active belief at that point. We add that to the truth table. That's the revised belief. We add the task to the truth table because they're different and they will have different evidence. And then we add the task to the task links, which is all relatively straightforward. Have you got any questions, Roman or Jared, on that?
No, I don't have any questions here. No, I don't.
Okay.
So we will keep in our table both revised belief or goal and original task, both of them.
Yes. Yes.
Okay.
And then goal is slightly more involved. So a goal task enters at the top. Again, we check for the existence of a truth table. If it doesn't exist, which it won't do initially, we skip around, etc. But let's assume it does. So truth table exists. We rank the truth table. So this is the beliefs we're ranking now. And importantly, this is by the task time. So they're going to be ranked by confidence projected to task time. Well, I mentioned that differently because down here, they're projected to the current moment. So there is a difference. It's an important one to understand. We won't go into the details about whether or not we'll change this. We'll just assume it's this for now. If we change it later, we'll talk about it then. So projected to task time. We then calculate the satisfaction. And the satisfaction is essentially, it's the difference between what the value of the goal is and what the value of the belief is. So if the belief is the same degree of completeness as the goal, then it's fully satisfied. So the satisfaction will be high, which means that we don't really need to do it because it's already been satisfied. Is that clear or not?
And what then if it is satisfied? What then?
Well, what happens is that the priority of the goal gets updated, and it would actually be set to very low because it's an already satisfied goal. So on that basis, it's far less likely to be selected from the task bag because it's got a very low priority.
Okay, but anyway, we will add it to task bag. Yes.
Yeah, we'll add it anyway. But the curve bag semantics mean that if it's the lowest priority, it won't
I
actually
understand.
end up going in there. Yeah. Okay.
Yes.
But we add it anyway. Then the bag takes care of the memory management aspect. So that section
But,
is sent.
yeah, one thing I want to add here, because it's for many people not clear that OpenNARS still does things, although it already achieved a certain goal. And the thing is, there is no such thing as achieved, because the truth value is only a matter of degree. And so it means when this is already processed and although it has a high satisfaction, it does not hurt to execute it again. The purpose of this updating goal priority is to let the system switch the attention to other things from now on. So if it's highly satisfied, it will still, if it came to this point, it will still execute it, but probably not again. It depends on how much priority and the attention of the system. Does this make sense?
Yeah, actually, it's kind of a realization that I came to only a little while ago myself about this, is that the system is kind of like, it's like local inference is like a cycle behind. And what I mean by that is that it hasn't necessarily executed the belief associated with the goal that you're currently processing yet, right? So whilst it will set priority, so for example, if it finds a belief that fully very highly satisfies the task, it will update the priority to be very low, but it hasn't actually executed that goal necessarily. So you still have to execute it, and hence my saying that the system's kind of like a cycle behind, because it's derived a belief that's a high match for this goal satisfaction, but it hasn't necessarily executed it yet. So the priority will drop, so it won't get executed again probably, but it hasn't yet been executed. So this step here still has to occur, otherwise it won't ever get executed.
Yeah, it's clear. I understand this.
Okay, good. All right. So
yeah, me too.
great. So we then move on to checking the desire table, and this is where the goals are stored. Again, if it doesn't exist, it creates it, but we'll assume it does exist for now. It now ranks the desires to the current moment. And as it says here, it's important it does this to the current moment because it's going to execute this function in the current moment. So hence, now is when it has to be projected to. It does the same thing with the task, projects that to the current moment. And then in the process, same as above, it filters them out and checks and returns the most revisable one. It either isn't or it isn't revisable. If it is revisable, the revised task, it revises the task with the highest rank desire. So that then becomes the revised task, if it exists, is what goes into this next step. So if the task contains an operation, as in something that can physically get executed by the system, it moves on to the next stage, where a decision threshold is checked to see whether or not it should actually execute that operation. And the decision rule is really just a threshold where it checks some of the metadata to see if it's above a certain level. If it isn't, it just nothing happens. If it is, then it executes the operation. So in our case, it sends an execution operation request message to the operator executor where it actually gets executed. If it's not an operation, it skips that piece and goes down to add the revised goal to the desire table if the revised goal exists, adds the task to the desire table, and that's it. So that is local inference for goals.
Yeah, it's pretty straightforward. Now,
It sounds like that, doesn't it?
it sounds like that. It's much clearer once now that you've made these diagrams. They're fantastic.
They're really great.
Okay, and the last bit is question, which is fairly straightforward. So if question task enter, so this is a yes/no question where it doesn't have any variables in the question. It's just a fixed question type like Tim Can, what's its truth value?
Also works for others because it will just go to the no case in case of a question variable.
Sorry, say that again, Patrick.
It also works for the question variable tasks because they don't have truth tables, so it will just go this way.
So it implicitly works for yes, nos, and all of the questions just pass because.
Oh,
no
sorry,
truth
I see what you mean. Yeah. Sorry, I'm with you. Thank you.
Right.
Yes, yeah, that's a nice little bonus. Yeah, because they're atomic concepts. There's no truth table. Yeah.
They are not necessarily atomic. You. Okay, I see what you mean.
Why? Okay, so the diagram that you drew. Remember the one that you drew with the question mark? What's a cat?
We can treat them as atomic concepts because we said atomic concepts. Either we can say atomic concepts are those who have an atomic stern, or they are those which don't have a belief or whatever.
Oh, I see. Sorry. Yeah. So different. I see what you mean. Yeah. So my definition that I'm using at the moment is that they don't have belief or goals or truth or desire tables. That makes them non-atomic. Otherwise, they're atomic. I see what you mean. You're thinking of it in terms of the concept or the term type, aren't you?
Right.
Okay. Yeah. Right, so that should still work then in that case. Okay, truth table. So the table exists. We rank the table by confidence projected to the task time, and the highest ranked value is the answer to the question. We select that. We update the best solution. Am I in the right place? Yes. We update the budget based on how well the solution has answered the question. So if it's very highly answered the question to a high degree, then the priority of the question will drop. If it's not a very good answer, the question's priority won't drop as much. If the question was asked by a user, then we output the answer to the display. Otherwise, we just add the task to task links. It's an important point here as well that we still process tasks even when we've answered them. And the curve bag semantics decide when they fall out of memory based on their priority level. So the questions have value in their own right, even though that we may well have answered the question, they still continue to try and get resolved to better levels of solution. Just linked to this, just the point Patrick brought up earlier, is the fact that in the belief table, we also maintain, sorry, not in the belief table, in the belief processing, we also maintain a list of questions in the concept that when a belief is added into the concept, we check to see if it answers any of the existing questions, which I need to put into the flowchart. If it does, then we update the user if it's a user question. Otherwise, we just update the priority of the question.
But is it related only to yes/no questions, or as I understand, Patrick said that we will check only answers for yes/no questions here.
Yes,
right.
yeah, because they're the only sort that will appear here.
Because this diagram will only be processed for beliefs. So since concepts with question variables don't have beliefs, this won't happen.
But actually, if we will have new belief, it can be a better answer for any kind of question, not only for yes/no question.
This is true. But the difference is that the answer cannot be found in the same concept if it's a question variable question. So if it's a what question, it has to search for solutions in other concepts, because there won't ever be an answer in the same.
Yeah, the point is, Roman, is that the question would never end up in this concept. So it would never go into the question table. So we could never check it had a solution, because that question will only ever go to an atomic concept, and that will not have a belief table in it. So the only way of answering the what type questions is through the general inference process, because they will never be in a table with a belief table.
Okay, so the only way to for questions with variables to be answered is to go through general inference in some moment.
Mm-hmm.
Yeah.
Right.
Okay. Yeah. Okay. Is it okay really? Because maybe we will not have answer for this question ever. So if this task will not be selected, it is okay, yes?
I mean, it's possible that you never have an answer. Yeah, that is true.
Actually, you have an answer, but you will never see this answer because, okay, it's if it's okay.
I see what you mean.
Yeah.
Mm-hmm. It can happen that the answer is not found. Although it matches, it did not select the relevant belief period, so did not recognize the answer yet. Although it's already in the system, this can happen. Mm-hmm.
Okay, if it's fine, no problem.
Yeah, and if you remember that the choice rule is responsible for handling this, so that will take a question and a belief from the general inference selection mechanism, and it will be executed as well as the normal deriver at the same time within the same cycle. If it happens to be a user question, it will output to the console in the same way as a normal yes/no question would.
Yes, I understand.
Oh, okay. Okay.
So I just wanted to say maybe we need to think about another way to handle this, or if you are sure that this is fine, that we can don't answer for this question. Okay.
Yes. I see that. Yes, it's fine. It's the thing is, if you have questions with question variables, there can be dozens of concepts which can potentially have an answer to this question, and it's not a good idea to spend so much resource just to guarantee that an answer to the question is recognized whenever it is in the system. So yes,
Okay, but
because
another moment, can I ask? So what if we will look for these answers when we add this new task? Because for now, if we have a new task with a question that has variables, we just add it to concept, and that's all. Maybe.
right, we add it in the concept, and this is it, right? Are you talking about yes, no questions, or about questions in it?
But why we cannot just look for answers for these questions right there in local inference?
Well,
No,
there's a couple of
because
reasons. You could, but you would have to search the
no,
entire concept space potentially for anything that was. So in the example of the cat, what? Anything that's got a cat as a second term is a potential answer.
it cannot use local inference because local inference happens only with the concept.
Okay, I see. You mean that there can be a lot of answers and that will be a problem. Okay, I see.
Yeah,
But
it's not just the initial answer, but you remember the system's constantly processing, so there may be better answer come out in a moment. Yeah, after it's done a few inference cycles, it will find another answer. So you'd have to do it every inference cycle to
okay,
find
I have
all the
another
possible
question.
changes.
But when we have this choice rule, so
Yep.
what actually answers we will check at this moment? What answers we will choose for this choice rule?
Oh, okay. So in this example that Patrick's put on the screen, the question that goes to the choice rule is what cat, and the tasks and the belief it happened to pick for this particular step of the inference cycle was Timcat. Now, Timcat is an answer to this question, right? So the choice rule would recognize that. Yes, this is an answer to that question. Then it has to check, is this a better answer to the question than I've already got stored in my task? If it says this is
okay.
a better answer, then I'll produce you this one.
We just collect our answers for every of these general inference cycles for this question. So if we have
just the best one, you don't need to collect anything other than the current best.
We just check the best. Okay.
Yeah.
Okay.
And
We don't check
keep a list.
all of them. We just check once.
Yes.
Okay. I see.
Yeah.
Thank you.
No problem. And also the other thing you have to check is if it's a user question, then you have to display the answer.
Yes.
If it's a new best
clear.
solution. Okay, great. Okay. This is one of those things that's more difficult to do with this design of concept. With the old concepts where all the terms related to where all the beliefs related to a single term were stored within a single bag. This is kind of easy because all the cat terms are all in the cat bag, and it was dead easy to find it because it was all in the same belief. In the same concept. But that doesn't work anymore. We understand why. We understand why, but it does make it more challenging.
Did I ever have an implementation with this model?
Yeah, it doesn't seem that it's not that difficult. Of course, it does rely on the control system now completely to find the answers. But to be honest, I think that's probably right.
I personally think that this design to keep order in a concept raises much more issues than the minimalistic design we have now.
Oh yeah. I'm completely sold on this approach. Don't get me wrong, especially with the temporal stuff. It's just it's different to how I've always done it up to now because all my beliefs were in the same concept. But that's fine. I don't have a problem with that. Okay. Any questions from anyone else? I think we kind of covered everything.
I don't have any
Neither.
questions.
Great. Oh, that's progress. Okay, so I will make those changes that we discussed, adding the question table to the concepts, making sure that's checked inside of local inference for beliefs. I will revise the notes around revisable and the truth tables so that it's clear how they're filtering and only only projecting revisable values. Anything else? I think that was it, really, wasn't it? Yeah. Okay, great.
Cool. Thanks, guys.
Thank
Thank you very much.
Have a good one.
Speak
Thank
soon.
you.